We are on to our last example of logarithmic differentiation. And the first two examples we did actually fall under the second case where you have a function to a function. Here we're in that first case where we have a combination of the product rule, the quotient rule, and some of these functions are raised to powers. Actually, all of them are. And so logarithmic differentiation can make this a little bit easier to differentiate. Okay. Let's begin by taking the natural log of each side here. Okay. Next, we have a little bit more algebra to do. Okay. So we still have the natural log of h of x, and so what I'm going to do first is we have this division going here. It's called a quotient, right? And we can rewrite this as the natural log of x to the 3/4 times the square root of x squared plus 1 minus the natural log of 3x plus 2 squared. And another thing we can do is we have a product here, and that product will be able to split up into a sum. Right, and so here's our sum. We're going to end up with the square root of x squared plus 1. But just to cut out a step here, I'm going to add an x squared plus 1 to the 1/2. And then we have minus the natural log of 3x plus 2 squared. We have one more log property that we can use here, and that is we can bring all those exponents out in front of the logarithms. So we can finish expanding this, and we get 3/4 times the natural log of x plus 1/2 times the natural log of x squared plus 1 minus the net, and I want to bring out that 2, so minus 2 times the natural log of 3x plus 2. Now, this may have felt like a lot of work, but after you do a couple of these, you'll be able to probably jump to this step immediately after taking the natural log of each side of the equation. Now that we have this fully expanded, let's go ahead and take the derivative with respect to x. Okay. So if we do that, we should get 1 over h of x times h prime of x. Right, that's our inside function h of x here, is equal to, and we'll get 3/4, and the derivative of the natural log of x is just 1 over x plus 1/2 times, and now we want to take the derivative of the natural log of x squared plus 1. So it's going to be 1 over x squared plus 1. And don't forget to multiply by the derivative of the inside, which would be 2x. And then we have minus 2 times 1 over 3x plus 2 times 3. And let's rewrite this a little bit. Let's maybe multiply both sides of the equation by h of x. And note, h of x, we know what that's equal to. It's this mess up here. X to the 3/4. I'm going to start writing it. X to the 3/4. The square root of, what was it, x squared plus 1 and then all over 3x plus 2 squared. So that's just me at the moment having multiplied by this 1 over, having multiplied by h of x on each side. Next, we still have everything that was already on the right-hand side that maybe we want to rewrite it a little bit. So we could rewrite this as 3 over 4x plus, and right, 2 times 1/2 is just 1, so we just end up with an x over x squared plus 1, and then minus 2 times 3 is 6. All right, and there is our derivative. Okay. And if we were really bored, we could try and combine these 3 rational expressions here to be just one rational expression. But we're not bored here, so we're going to stop right here.